3.2 is histograms. It says, while a frequency distribution is useful for summarizing data, it's even better maybe to use a histogram. That's a graph that's easier to interpret than a table of numbers. A histogram is a graph consisting of bars of equal width drawn adjacent to each other unless there are gaps in the data. All right, so it's like a bar graph. And one thing that's weird, I think, it's a bar graph, but there's when they say adjacent to each other, they're saying no gaps. So the bars are just stuck to each other, basically. Bar, 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 bar. No space in between. I don't know why that's a big deal, but for now, that's what it's saying. Horizontal scale represents the classes. We talked about classes last time, or the categories, or the rows. And the vertical scale represents the frequencies. So it's the same information as last lesson with the frequency distribution, but it's just a picture of it, a bar graph of it. The heights of the bars correspond to the frequency of the frequency values. So this might be a homework question. The heights of the bars correspond to the frequency values. Important uses: visually displays the distribution. Sometimes that's like a bell shape. Shows the location of the center of the data. That's like mean, median, and mode type stuff. Shows the spread, identifies outliers. Relative frequency histogram has the same shape and horizontal scale as a histogram, but the vertical scale is marked with relative frequencies instead of actual frequencies. So remember when we talked about relative frequencies before, we were talking about percents. The chart that I'm looking at right there does not look like percents to me. Those are not percents. How they would do percents is divide by the total. That total is 35, 45, 50, and then times 100. So that's 22%, and that's 48%. That's 20%, 6%, 4%. So that table is what we did last time. That's our frequency distribution, but the histogram is that bar graph. So, is it easier to see the data in the histogram? Maybe. It's a nice picture that shows how high this is compared to the rest of them. So it's just a nice visual interpretation. Explore the data by analyzing the histogram. Look for the center of data, the variation, the distribution, the outliers, and time. So this is not a helpful acronym, I guess, but CIVDOT, center, variation, distribution, outliers, and time. That is a T for time right there. So those 5 things are what we're looking for: center, variation, distribution, outliers, and time. Again, time is whether there's a change in data over time. So common distribution shapes. This one is the most comfortable for me. The first one is a bell-shaped or a normal distribution. We can see the center, and we can see the variation. The distribution was the shape, right? Outliers, I don't see any outliers. Outliers would be if there are numbers like way over here, way far away from the others. And the change in the time, I guess, might be it goes up and it goes down. So then the next one, the uniform. Uniform means same, right? Uniform means same. And so, yeah, this looks like they're all the numbers are pretty much the same. I think that makes sense for that shape or that distribution. It's hard to find the center, really, of those numbers. because they're all the same. Next one. To me, this seems backwards. When it says skewed to the right, it just feels like that's backwards. It feels like the shape is skewed to the left. So understand that they're talking about this tail. All right, the longer tail is to the right. So if one side has a longer tail, that's the direction that it's skewed to. This is skewed to the right, or otherwise called positively skewed. Positively skewed to the right. So then the next one, when it has a longer left tail, it's skewed to the left, or negatively. Negatively skewed, longer left tail. Are you guys missing this? Oh, I see where we're at. Okay, sorry. Normal distribution. Because this histogram is roughly bell-shaped, we say this has a normal distribution. All right, so we've seen this one. We've seen this one kind of a lot. That's the distribution or the shape. And it comes up kind of a lot. Skewness, I already talked about this. The distribution of data is skewed if it is not symmetric and extends more to one side than the other. So this one is to the right. This one is to the left. I already mentioned that, just to repeat myself. Okay, assessing normality. Normal distribution, it says the pattern of the points in the normal quantile plot is reasonably close to a straight line, and the points do not show some systematic pattern that is not a straight line pattern. That's a lot of words, and that's kind of hard to understand, I think. All right, but look at those dots. Those dots pretty much make a straight line. They pretty much make a straight line, but not some other pattern. That's normal. Okay, that's a normal distribution. But then the next slide shows things that are not a normal distribution. So if it's not a normal distribution, if the points do not lie reasonably close to a straight line pattern. And so, you know, when I first looked at this, I looked at these dots and I'm like, well, what is this? But then I thought, oh yeah, here's a whole bunch of dots right there. That's definitely not a straight line pattern. Okay, not a straight line pattern. And then I looked at the next one and I'm like, yeah, those dots are pretty much straight, but it says there's some systematic pattern that's not a straight line. See how it kind of looks like a sine wave or something? That's definitely in some kind of pattern that's not straight. All right, so either one of those two things happen. It's not a straight line, or it's some weird pattern that's not a straight line. That's not a normal distribution.